I'm Anil Kumar. Welcome to my series on calculus. I'm discussing with you questions from previous test paper on related rates. We have 8 questions to discuss in this particular video, and I hope that will prepare you well for this unit. You can always pause the video, copy these questions, work them out, and then look into my suggestions. So you can see the first 4 questions now. Here are the other 4 questions of this test paper. Right? So we'll now take them one by one. Question number 1. The side of a square is increasing at the rate of 3 centimeters per second. At what rate is the area increasing when the side length is 5 centimeters? So let us say we have a square. So we'll just make a small sketch on the side. Write down what is given, right? What formulas are required, and then work out the details. So we are saying this is our square whose side lengths are s each. The side of a square is increasing at the rate of 3 centimeters per second. That means ds dt is 3 centimeters per second, right? At what rate is the area increasing when the side length is 5 centimeters? So we are given, let me write down given and then find. And what do we need to find? We need to find the rate of increase in area. So that is dA dt when side length is 5 centimeters, when s is equals to 5 centimeters. Correct. So that is the equation for us. Now let's write the relation between area and the side length. So area of a square is equal to side length square. Differentiate with respect to time. So we get dA dt is equals to 2 times s times ds dt. So we need to find area, change in area, when s is 5. So let's substitute these given values. So we have dA dt when s equals to 5. Substituting, we get 2 times 5, and ds dt is 3. So we get 3. Area is centimeter square per second. Correct? So we get our answer, which is 10 times 3 is 30 centimeters square per second. Clear? So that is how we are going to get the solutions to all our questions, right? If you want, you can write specifically the answer separately. So it will be 30 centimeters square per second. Correct? Now let's take the second question. A toy car moves along a straight line so that after t seconds its displacement from the origin in meters is s meters. Given that s of t is minus 2 t cube plus 6t square, t is between 0 to 5, determine an expression for velocity and acceleration at time t. Initial velocity and initial acceleration. The toy car's maximum velocity. When is the toy car moving towards its initial position? Correct? So in this case, what we are given? We are given the displacement, right? S of t as equals to minus 2 t cube plus 6t square, and that is under a boundary condition where time is between 0 to 5, both included. Now part A of this question is expression for velocity and acceleration at time t. So that is the derivative, right? So the velocity at any time t is the derivative d dt of s of t, correct? So which will be minus 6t square plus 12t. Right. So that becomes the expression for velocity. B, initial velocity, and let's also find acceleration. So A will do acceleration as derivative of velocity. We can write this as v dash t, which is going to be minus 12t plus 12. Okay, so that becomes the expression for acceleration. Now part B is initial velocity and initial acceleration. When we say initial, that means time is 0, right? So it's just the starting point. So for part B, velocity initial, that means v0. Substitute 0 here, we get 0. The units are meters per second, right? So meters per second. And here, acceleration, initial acceleration. When I substitute 0 here, we get 12 meters per second square, correct? Part C is the toy car's maximum velocity. Now to find the maximum velocity, we need to check when is the velocity, when is the acceleration? 0, right? So it's a turning point, correct? So for part C, what we are going to do is we have to find when is acceleration 0. So we need to find the critical number. That means a of t should be equal to 0, right? So substituting that, if I write 0 equals to minus 12 t plus 12, so that really gives you that t is equal to 1, right? So 1 second. So at t equals to 1 second, we have a critical number. Now we need to verify whether at this critical number we have a maximum velocity or a minimum velocity, right? So that is what you need to check. Since you are also given a boundary condition, you can also check with the boundary condition in this particular case, right? There's only one critical number at this stage. So what we will do here is that we'll check the velocity at t equals to 1, 0 and 5. We already have an expression for velocity which is right there. So velocity at 0 we know is 0, right? Velocity at 1 is, substituting 1 here, we get minus 6 plus 12, which is equal to 6. And then let's check velocity at 5. At 5, it will be minus 6 times 5 square plus 12 times 5. Correct? So which is, let's use the calculator. So 12 times 5 is 60. Take away 25 times 6. So that is negative 90, right? So that is the lowest velocity. So we have the maximum. So therefore, maximum velocity is at our critical number, which is t equals to 1 second, right? So the toy car's maximum velocity is how much? And this maximum velocity is 6 meters per second. Is that clear to you? So that is going to be our solution for this part. Now for part D, let's move on and do it on a fresh page. When is the toy car moving towards its initial position? Now how do you figure this out? Now, important thing to understand here is that the product of the displacement and the velocity, if it is less than 0, that means it is negative, then it is towards initial position. Is that clear to you, right? So that is the condition. So we are going to just test the product of displacement and velocity. So let's work it out. S of t is minus 2t cube plus 6t square. You could write this in factored form also. So if I take minus 2 common, in rather t square, minus 2t square common, so I get t minus 3. Right. So that becomes a factor. Now minus 2t and t minus 3. As far as the velocity is concerned, we just found derivative of this, so which is minus 6t square plus 12t, right? So we can take minus 6t common, so that gives us t minus 2. So the product S of t times v of t is what? Product of these two. So which we get as minus and minus becomes positive. 6 times 2 is 12. T times t square is t cube. And here we get t minus 3 times t minus 2. So that is what we get. So we have critical numbers at 0, 3 and 2. So we can test in between these. That is one way of doing it. So let us do that testing. So we'll make a table of values to test. You could also use a graph to figure this solution. So here we have t as equal to 0, t as equal to 2 and t equals to 3. So let's take a test point on either side. So we are only worried about the right side. So test point could be 1, 2.5 and let's say 4. The factors are to be tested 12t cube, then we have t minus 3 and we have t minus 2. So when this is positive, 12t cube will be positive. T minus 3, that is going to be negative only after 4. Only positive after 4, right? So before that it's going to be negative. T minus 2 will be negative for t equals to 1 and thereafter it is going to be positive. Now when you multiply these three, what do you get? You get two negatives means a positive, and here one negative means a negative, and that is also positive. Correct? Now it's a cubic function. Some of you could have drawn a graph also. Leading coefficient here is positive, so the graph will be going through these zeros, right? These are like zeros, correct? So we have a zero which is kind of like this. Is that okay? Now this is cubic, right? So this will be kind of like this. So that is how we have, and that is the interval where the product displacement and velocity is negative, and that is the time during which the object, toy car in this case, is moving towards the initial position, right? So we can now write down our answer, and our answer is that the toy car is moving towards initial position during interval which we can write as an inequality between 2 and 3 in seconds, right? So time is in seconds, time in seconds. Is that clear to you? So that is how this question can be answered. So I hope the concept is absolutely clear. Right? Question number 3. Air is being pumped into a spherical balloon at the rate of 7 pi centimeter cube per second, right? So let's say that is our spherical balloon, and air is being pumped at a rate of this. That means change in volume, right? So we have dV dt is given to us, which is 7 pi centimeter cube per second. Determine the rate of change in balloon's radius. That means we need to find dr dt when the volume of the air in the balloon is 36 pi centimeter cube. When the volume is equal to 36 pi. Now, we are not given the radius, we are given the volume. So in such cases, we need to figure out how much will be the radius for the given volume, correct? So that is one step. So in such cases, we need to find the radius. Now we know that the volume is 4 by 3 pi r cube. Now we can use this relation to get the answer. So let's use this relation. Volume is 36 pi. So for 36 pi, 4 by 3 pi r cube. So pi and pi cancel, and let's multiply this. We have 36 times 3 over 4 is r cube. So we get 9 times 3, which is 27, is r cube. So cube root of 27, which is 3, will become r, right? So r is equals to 3. Okay. So basically at this time we now have worked out that r is equals to 3 units. Now we can continue and then find the solution. Okay. So that is sometimes required. So once again we have volume as 4 by 3 pi r cube. Let's find the rate of change of volume with time. So we have dv dt equal to 4 by 3 pi times 3 r square dr dt. Simplifying, we can get dv dt as equal to 3 and 3 cancel, and we have 4 pi r square dr dt. We need to find dr dt when r is 3. Correct? We know dv dt is 7 pi. So let's substitute these values. dv dt is 7 pi equals to 4 pi. R is given to us as 3 square, and we need to find what is dr dt. Is that clear to you? So we substituted the values, which are r equals to 3. Correct? Now at that time dv dt we know is a constant, 7 pi centimeter cube, and we are considering this to be a sphere of radius r units. So let's simplify this. So we get dr dt as equal to, let me write it here on this side, dr dt as equal to 7 pi over 4 pi times 9. Correct. So pi and pi cancel. So we get 7 over 36. So that is the rate, and the units will be centimeter per second. So the rate of change of balloon's radius, so we can write down now the answer, that the rate of change of balloon radius with time when the volume is 36 pi is equal to 7 over 36 centimeters per second. Clear? So that is how we are going to solve this. Let's move on and take the next question. Now let's take up question number 4. A 10-meter long industrial ladder is leaning against a wall on a building site. The top of the ladder starts moving down the wall at the rate of 0.5 meters per second. Determine how fast is the foot of the ladder moving along the ground when it is 6 meters from the wall. So let's make a small sketch here. Let's say that is the wall, and this is the ground. Ladder 10 meter long is kind of like this. Okay. So we're given this is 10. So 10 meter long is leaning against a wall. The top of the ladder is moving down. So this top is moving down, and the rate is 0.5 meters per second. So we can say dy dt is equals to minus 0.5 meters per second, since it is moving down. Determine how fast is the foot of the ladder. So that foot of the ladder is moving. So we need to find what is dx dt when it is 6 meters from the wall. When this x is equal to 6, right? That is what we need to figure out. So that is the question for us. Now, in this case, we are using that as y and x and fixed length of 10. So the relation which connects them is x square plus y square equals to 10 square. Okay, so that is the relation. We can find the derivative with respect to, differentiate with respect to time. So we get 2 times x dx dt plus 2 times y dy dt is equal to 0, since the derivative of a constant is 0. Now, when x is 6, at that time, what is y? So we should also figure this out. So we'll do, when x is 6, we can write y is equal to 10 square minus 6 square root. When x is 6, right? So this is what the condition will be. So that gives you 100 minus 64 square root, right? So that is sorry, 64 is 36. Okay, sorry. So 100 minus 6 square is 36. And when you take away 36, we get 64 square root, which is 8, right? So we get this as 8. So y is 8 when x is 6. We can write here, when x is 6, y is equal to 8. We're going to need both the values of x and y, and that's why I made this change, correct? Okay. Now, you can always cancel 2 from these places. So what we get here is x times dx dt plus y times dy dt is equal to 0. Now, since we need to find dx dt, let's isolate this. So we have dx dt as equal to, taking this on this side, minus y over x dy dt. We know x, y, dy dt, and so we can always find dx dt where x is equal to 6. So that gives you y value is 8, x value is 6, dy dt is minus 0.5 or half, correct? So this can be calculated. So what we get here is half of this, which is 4 over 6 or 2 over 3. Correct? So half of 8 is 4, and 4 divided by 6 is 2 over 3, positive sign. And the units are going to be meters per second. Is that clear? So what we notice here is that we can write down our answer here, that the ladder slides at the rate of 2 over 3 meters per second. Perfect. Question number 5 here is, a conical tank is being filled with water at the rate of 2 pi meter cube per minute. The radius at the top is 4 meters and its height is 8 meters. How fast is the water level rising when it is 5 meter deep? So let's make a rough sketch. So that's the kind of cone which we have, and says that the rate at which it is being filled is 2 pi meter cube. So that is the volume, right? So dv dt is 2 pi meter cube per minute. The radius at the top is, so the radius is 4 meters. So this is 4 meters. And the height is 8. So if I take a cross section, then we could actually do it like this, that 4 and 8 is the total height. How fast is the water level rising when it is 5 meter deep? So 5 meter deep, let's consider as, so we want at this stage, how fast is the water level rising, since we are pouring in water at a given rate, right? So that's the question. So I hope the question is absolutely clear. Wherever there is a conical tank or a flask included, we have to do similar triangles, right? So from similar triangles, you can see that the ratio of height to radius is same, right? So radius to height, the ratio here is radius is 4 and height is 8. So that is going to be maintained. So this relates height and radius. We need to find how fast is the water level rising when it is 5 meters deep. That means we need to find dh dt, right? So we need to find dh dt. So we'll write radius in terms of height, correct? So let's develop the relation which is going to help us solve the question. Volume for a cone is 1 by 3 pi r square h, correct? And from here we know that r over h is 2, right? R over h is 1 over 2, right? So it's half. So we can write what is r in terms of h. So this gives you r equals to half of height, correct? So replacing that, we get the volume as 1 by 3 pi h by 2 whole square times h, or you can say volume is 1 by 3 pi h square times h is h cube, we can write, and 2 square is 4. Correct? So we have volume as 1 over 12 pi h cube. So differentiating volume with respect to time, we get this as 1 by 12 pi times 3 h square dh dt, correct? So that is the expression which you get once you differentiate this with respect to time, right? We need to find the rate of change of height when the height is given to you as 5 meters. That's what we need to find. Is it okay? So we need to find what is dh dt when h equals to 5. We know dv dt is 2 pi, so we'll substitute these values, isolate dh dt. So we can from here get dh dt as equal to, now you can simplify this, dividing this, we get 4 here. So cross multiply, so we get 4 in the numerator. The denominator is pi h square dv dt. Correct? So now dh dt for height equals to 5 will be 4 over pi 5 square, and dv dt is 2 pi. So that becomes the value. So 8 over 25. Units will be, we want to find rate of change of height in meters, meters per minute. Is that clear? So that is how we are going to answer this particular question. Now let's take up the next question, which is question number 6. A point moves along a curve y equals to square root of x square plus 1 in such a way that dx dt is 4 units per second. Determine dy dt when x is square root 3 units, right? So we are given y equals to square root of x square plus 1. We are also given that dx dt is 4 units per second, and we need to find what is dy dt when x equals to square root of 3. Right? So let's find the derivative here. So we get dy dt equals to what? Dy dt is equal to, now that is to the power of half, so it will be 1 over 2 square root of x square plus 1 times derivative of inside function, which is 2x times dx dt, right? Since we are differentiating with respect to x. Now to find dy dt at x equals to square root of 3, we know all these components, so it is easy to calculate, right? Just substituting the values, we get our answer. So we get dy dt at x equals to square root of 3 should be equal to 1 over 2 square root of 3 plus 1 times 2 times square root of 3, and dx dt is given to us as 4, correct? So that is what it is. We can simplify this and then write down our answer, which is, this is square root of 4, which is 2, right? So we'll just do it in 2 steps. We get 4 square root 3 over square root of 4, which is 2. So we get 2 square root 3 as our answer, and dy dt will be units per second. Correct? So in our case, the answer will be 2 square root 3 units per second. Question number 7. The surface area of a closed cylinder is given by A equals to, let's write down the formula, 2 pi r square plus 2 pi r h. H is the height and r is the radius of the base. At the time that the surface area is increasing at the rate of 20 pi centimeter square, so surface area is increasing, so dA dt at 20 pi centimeter square per second. The radius is 4 centimeter. We are given r is 4 and the height is 1 and height is 1 centimeter. And the height is decreasing at the rate of 2 centimeters per second. So we are given dh dt seconds. So write minus 2 centimeters per second. Determine the rate of change in radius at this time. So we have to find rate of change of radius at this time. Right? This is what we need to figure out. Now we have the expression. We can just find derivative with respect to time. So we get A equals to 2 pi r square plus 2 pi r h. dA dt will be 2 times 2, 4 pi r dr dt plus, now here both r and h are changing, right? So we'll have to use a product rule in this particular case. So we get 2 pi is a constant, right? And r and h. So if I have a derivative of r, it is dr dt times h plus r times dh dt. Is that clear to you? So that becomes the rate of change of area at a given time. We need to find what is dr dt, right? So that's what we need to find. So we can always isolate that, or we can just let's isolate. That's not a problem. So we'll write dr dt. So here we have 4 pi r, and here dr dt is 2 pi h. The other term is 2 pi r dh dt, right? So plus we have 2 pi r dh dt, correct? So now from here we can get what is dr dt equals to. So dr dt is equal to dA dt minus 2 pi r dh dt, correct? And we'll divide all this by 1 over, that is multiply with 2 pi r plus 2 pi h, 4 pi r plus 2 pi h, correct? Let's see value. So dA dt is given to us as 20 pi. So we have 20 pi minus 2 pi r dh dt is minus 2. So minus 2 divided by 4 pi r. R is given to us as 4. I should have written 4 here for r also. So r is given to us as 4. So 4 times 4 is 16 pi plus 2 pi times h, and h is given to us as 1, right? So times 1. So that's what we have. Now pi is common, so let's just cancel pi from all the factors, and then we'll simplify this to get the result. So we have 20 minus and minus becomes plus, and 4 times 4 is 16. So 20 plus 16 is 36 over 16 plus 2 is 18, and so we get 2. Correct? So dr dt is 2, and the units will be centimeters per second. So let me write down here dr dt is equals to 2 centimeters per second. Is that clear to you, right? So you may have to rearrange things like that, but you could substitute the values directly and then isolate dr dt to find the result. Don't forget to apply product rule at this stage. So I hope that makes sense. Question number 8. The ends of a water trough 1 meter long are equilateral triangles. Water is poured into the container at the rate of 20 centimeter cube per second. Find the rate of change in the height of the water when the height is 10 centimeters. Okay, so basically we have a triangular section which is kind of like this. Let's just make one triangle here, and that is the top, right? So it is again triangular like this. So let me just sketch a triangle here. Parallel side, so that is on the bottom, right? Let's say like this, and this is kind of like this. So that becomes a triangular trough. Now in this particular case, what we need to relate is height, right, with the area of this triangle, right? The ends of a water trough 1 meter long, so we are already given that this length is 1 meter, which is 100 centimeters, correct? Water is being poured at a rate of, so change in volume is dV dt, which is 20 centimeter cube per second. Find the rate of change in the height, so we need to find what is dH dt when the height is 10. So basically we need to find expression for volume, that is the first thing. So area of an equilateral triangle, let's figure out that first. So let us say this is the height. We are given that the angle here is 60 degrees, correct? All sides will be equal. So let's find what this side will be. So let us say this side is S. In this case, side S over, that is the hypotenuse, correct? Side S is the hypotenuse which we need to find. So we know that sine, this is opposite side, correct? So we can say sine of 60 degrees will be equal to opposite side over the hypotenuse, so H over S, correct? And in an equilateral triangle, you know the ratios. Let's sketch one here on the side. This is half of the equilateral triangle, which I normally use. So that is 60 degrees. So 1, 2, square root 3. These are the ratios of the sides. 30, 60, 90 triangle, correct? So sine 60 is square root 3 over 2. So you could write this as square root 3 over 2 is H over S. So each side length, you can now write that each side length S is equal to 2 over square root 3 times height. Is that clear to you? Right? So that is a relation which is well known and should be very clear in your mind before you start doing this question. So that gives us the formula for area, which is half base into height, correct? So we get the volume as equals to area is half, base is S, right, which is all this, which is 2 over square root 3 H, that is the base, times height times the length, which is 100. Is that clear to you? So that becomes the formula for the volume, which is basically area of triangle times length. So for any particular height h in general, that is going to be the relation, because it's going to be equilateral triangle all the time, correct? So I hope this part is clear. So first thing is to get the volume. So this 2 and 2 cancel, and we have h square over square root 3 times 100. So that becomes the volume. Now rate of change of volume with height will be dV dt, and this will be differentiating both sides with reference to time, correct? So we get 2h dH dt, correct? As far as the constant is concerned, it is 100 over square root 3. Clear? Now from here, we can easily find what the rate of change of height is, which we are interested in finding. And when h is 10, correct? So we can just substitute these values. So we can isolate dh dt. So we can say that, let's do it on the right side. So we have dh dt, rate of change of height is equal to, that square root 3 will come in the numerator, over 200h. Correct? So times dv dt. Right. Substituting the values, we get dh dt for height equals to 10. So it will be square root of 3 over 2000. dv dt is given to us as 20 centimeter cube per second. We'll just multiply by 20. Right. So that goes 100 times. So basically square root 3 over 100. And the units are going to be centimeter cube, centimeter per second. So that's how we're going to get our answer. So our answer is square root 3 over 100 centimeters per second. Is that clear to you? So I hope with this you understand how should we be solving questions based on rate of change. Correct? So in this video we took up 8 questions from previous test papers. So that is the variety. If you are working with this video, you should be in a position to get good marks in your test on related rates. Perfect. So these were the 8 questions which we just did. I hope it makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.